So previously we had seen the lazy subset construction. I'm going to show you a couple of examples of applying it. So I'm going to remind you of some of the steps in our first example, and then we'll go a little faster on our second example. So let's consider the following NFA, or non-deterministic finite automaton. So we're going to call this one N1, but here we go. It's going to have three states, Q0, Q1, and Q2. Q1 is going to be a final state. The start state is going to be Q0 here, just to keep things simple for us. We're going to have 1 and a 0 leaving Q0 on Q2 and Q1 respectively. We're going to have a self loop with a 0 and a 1 on Q0. And we're going to have a transition from Q2 to Q1 on a 1. So this is our NFA and 1. And we're going to be applying the lazy subset construction to the following NFA. So applying the lazy subset construction on N1, we obtain DFA D1 as follows. So let's walk through this process carefully. So I'm going to use the transition table. So remember, we have two input symbols, 0 and 1. The DFA is always going to have as a subset, because Q0 is the start state, it's going to be this subset specifically. That's going to be the start state. And now we're going to go through this process. So let's check this out. So on state Q0, because that's the only state we have in this subset, remember it's a label, right? This is a label. So on Q0, when I read a 0, it goes Q0 to Q1, right? So it stays in Q0, but it also can go to Q1. So I have the subset Q0, Q1. And on a 1, when I read a 1, it stays in Q0, but it can also go to Q2. So notice that I discovered Q0, Q1 first. So I'm just going to write a row for that because that's what I'm supposed to do. Q0, Q1. Naturally, next one I would do one for a row for is this one right here. So for Q0, Q1, okay. Q0, Q1. So on Q0, when I read a 0, it says, akin to what I had before, it should be Q0, Q1 is the subset. Then I have to consider Q1. So remember, I'm going to consider the transitions out from that state. And I'm going to take, from each one of these, I'm just going to lump the states together in one subset appropriately. So in Q1, when I read a 0, there are no transitions out of Q1, right? So it's the empty set. So it means that the resulting entry here is Q0, Q1. Just like the one just above it. Interesting enough. Now we have on a 1, Q0. Q0 on a 1 goes Q0, Q2. So it transitions into two states, Q0 and Q2. And for Q1, again, doesn't transition anywhere. It dies. So Q0, Q2. Exact same one. So next, I have Q0, Q2. That was the next one I discovered. I don't have a row for it though. So I'm going to now add a row for that. So next, say Q0, Q2. When I read a 0, it's Q0, Q1 for Q0. And on 0, notice there's no transitions out of Q2, so it's just going to be Q0, Q1 again. However, on a 1, Q0, on a 0 stays in Q0, but also goes to Q1. But also, if it's in Q2 on a 1, it goes to Q1. So that means it actually will include every one of the states. Naturally, I've just discovered another state that for which there isn't a row. Q0, Q1, and Q2. Okay, so now I have all three of the states from the NFA. So Q0 on a 0 is Q0, Q1, right? On Q1, upon reading a 0, nothing. That's the empty set. Q2 on a 0, nothing. So it's just going to be Q0, Q1 again. How about on a 1 for this subset? What would it be? It's going to be, okay, Q0 goes Q0, Q2, right? On 1. On Q1, nothing. Right, remember this is for Q0. This is Q1. And for Q2, on a 1 goes to Q1, right? So notice that it's just the same subset again. It's Q0, Q1, Q2. We're not quite done labeling our transition table, right? Sorry, I'm getting really excited here. Okay, there's only Q1 is the final state, so I need to indicate the final states. So Q0, Q1, that one is a final state, and this bottom one is as well, because both of them contain Q1. That's how we know it should be a final state in the DFA. So I encourage you now to draw this as the transition diagram for this DFA. Also, I encourage you to relabel this DFA so that they just don't look like subsets anymore. But this is me applying the lazy subset construction. Notice that it does not contain any states that are unreachable from the start state. So that's the benefit of the lazy subset construction over its vanilla counterpart. So let's do another example. So let's consider the following NFA. So again, 3 states. I like to keep it simple, but remember the principles apply here. Remember, the idea is that we're trying to explore by taking 1 step into the graph, 2 steps in the graph, 3 steps in the graph, and the subsets in question are those for which we have states for the DFA in the end. So remember, as we discover states, whenever they don't have a row, we include a row for them in a breadth-wise manner. That just keeps it easy for us to keep track of them. You can actually imagine this as if every time I encounter a state that is discovered but we don't have a row for it, I put it in a queue. Just like you would in a breadth-first search, because those subsets correspond to vertices that are states for the DFA. So here we go. So imagine this is NFA N2. We're going to build the DFA D2 using the lazy subset construction. So I'm going to draw out the transition table. I find it's easy to keep track of that way. So I have 2 input symbols, A and B. So remember Q0, oh, I got to put the start state. Don't forget that. That's really important. Not to forget indicating the start states. I will tell you up front, you don't want to forget indicating little details like that in your transition diagrams. Start states, final states, labeling transitions. Otherwise, you may have an incomplete description for your NFA or DFA. So this would be the start state because Q0 is the start state. This is the subset in question for our DFA. So I'm going to indicate it as the start state. Okay. When I read an A on this, so I look at each state in here. Q0 on an A. The only one it can transition to is Q1. On B, there's nothing there, right? So now I've discovered this state and I've discovered this state, or subsets. I've discovered these two. However, they don't have rows, so I'm going to examine this one first because I discovered that one first, then I'm going to do this one next. Notice that as long as you do it in an order for which it's easy to keep track of, you're okay. So you can imagine like you evaluated B first versus A, doesn't matter. Doesn't matter. Okay, so next we have Q1. Okay, Q1 on an A. Notice there's no transitions out on A. So we've encountered the empty set, which again, now this is it. We haven't yet added a row for this one, but I've already noticed it. It's already somewhere hiding around, right? We will account for that state. Then I have Q1, Q2, right? It could stay in Q1 or it could be in Q2. Next, I have the empty set. Okay, on the empty set, I don't have any states, right? I don't have any states. It's pretty much a piece of cake. Then I have this one. This was the next one I've discovered, but doesn't have a row. So Q1, Q2. So in Q1 or Q2, when I read an A, nothing, right? However, on B, Q1 can transition into Q1 or Q2. And Q2, there's nothing going in and out of Q2. Sorry, there's things coming in, but nothing going out. So we end up with Q1, Q2 again. Notice that now I have all of the discovered states, but all of them have a row now. Notice that Q2 is the only one with a final state, so I'm going to indicate that appropriately for our transition table. And finally, let's draw the picture. Let's see what the transition diagram looks like. So this is what D2 will look like. So we're going to have the state for which it's Q0 like this, right? Okay, on A, it goes to a state labeled by the subset Q1. Does that on an A. However, on a B, it goes to this state labeled by the empty set. Okay, so now on Q1, on an A, it transitions over to the state on the empty set. On B, however, it transitions to Q1, Q2, so that's another state. That'll be our last of the four states. It's a final state. On the empty set, it transitions on the empty set regardless of which symbol you have. And then finally, on A, Q1, Q2 goes to this so-called, by the way, these states right here, this is often called a dead state. Sometimes when people talk about DFAs where they have a dead state, they may actually just straight up omit this state, although technically speaking, that is in fact an NFA once you remove this state from the transition diagram. But sometimes implicitly, you may want to just describe a DFA where it has these so-called dead states accounted for. But it's technically speaking, if you didn't include this state in the DFA, it would be an NFA because you would actually not be labeling all the possible transitions. It'd be implicit that it actually just, the thread dies for that appropriate state. Because remember, It's still an NFA if that's the case, right? Because in the transition function for NFA, you're allowed to pick any subset of the states that includes none. So I just thought I would mention that. In practice, some people will draw the DFA for which when they need a dead state, they'll just simply not include that in the transition diagram because it makes it really ugly. Because you can imagine you have many states, they all have arrows pointing at one single state. But remember, technically speaking, when you end up with like removing this explicitly, it is actually an NFA. And in fact, a neat thing about the subset construction is when you apply it to that NFA, you end up with one with the dead state in it. So lastly, we got one last guy right here on the B, on a B. There you go. So there's the resulting transition diagram for, this is DFA D2. This is the transition diagram for DFA D2. So I thought it'd be a good idea. We've seen a couple of examples of applying the lazy subset construction. Pretty nifty, right? So that's the subset construction.